Assalamu alaikum. The name of our project is Fault Detection using Machine Learning in the Power System of Bangladesh Southwest part, which covers the area of Sundarban, Khulna and Barisal coastal area. Presented by MD Alamin Patwari, Shomik Shantomondol, MD Monabirul Islam, MD Ahsanur Rahman, Shoaib Akhtar Rafi and MD Tasbik Rahman. First of all, we would like to show the entire timeline of our project. First of all, we wanted to select an area which is susceptible to huge fault and frequent fault occurs there. In this case, we have selected Khulna Barisal coastal area. Next, we have generated a train model using MATLAB Simulink. After that, we have selected 5 locations where we started the study of fault. How? To do so, we have placed a voltage current measurement meter at the point of fault and measured both symmetric and asymmetric, including line to line and ground, line to ground and so on, this type of fault. After that, we have generated a dataset based on this study. Finally, we have trained this data into conventional neural network, gated recurrent network and decision tree classifier. It has been done in Python. After that, we analyzed our result and choose the best trained model of our faulted network. Let's go in details. This is our motherland, Bangladesh. We have selected this area, Khulna to Barisal, like this. This is a report from Windy website. It was found during the cyclone Amphan attacked in our area. Since most of the cyclone and tornado comes to our country through this path, mainly Satkhira, Khulna, this portion, so we have selected this region as our point of interest. Next, we have went through the website of PGCB and collected that map covering the area of Khulna to Barisal, Potuakhali, this portion Satkhira, Goalpara, Bhandaria, Bagerhat, mainly this area. Next, we have selected a fault here, the line coming from Khulna to Satkhira. Another fault here, Khulna Power Company Limited. Here there is G means there is a power plant. Another one is NW PGCL, Northwest Power Company Limited. Another portion of fault we have selected here, Orion Rupsha. Finally, another fault near the district Barisal, near the power generation plant Summit. After that, we need to know the nature of load forecasting to set our model in Simulink. To do so, we have find a data set from the month of April 2022 from PGCB website, and here we have find in these two column. The first column in the arrow show the day load demand, and the second column shows the night or evening load demand. In is here you can see this in Khulna district. Khulna is Mongla Orion, and we have using this Rupsha Orion portion. Here you can see 105 watt is needed for Rupsha portion. Now I will show how we have distributed this load into our different substation. So here is our assumption. First of all, you can see there is 105. If 3 substation is connected with this Rupsha portion, then it will be divided by 105 by 3, means 35 megawatt will be distributed in each substation. Here we have divided, here we have not considered the substation transformer which convert like main line 132 kilovolt to 60 kilovolt 66 kilovolt. We have ignored that. We directly goes in this pattern, like in the supply portion power will be generated in 33 kilovolt, and in the transmission line it will be converted from 33 kilovolt to 132 kilovolt. After that, at the load side we have directly step down it from 132 to 400 volt for the consumption area. Here we have ignored the portion of substation for our simplicity. Here this is our network. So now it seems very fuzzy, so I am going to zoom it in every portion by portion. Let me start. This portion is the area of KPCL, Khulna Power Company Limited, Golamari and NWCL. Next, this portion covers the area of Satkhira. Next, this portion covers the area of Goalpara, and another we can see at the right side there is source coming from Orion Rupsha. Now you can see 105 megawatt, right? It will be divided equally in every load connected with it. We have assumed that. In real life it's quite different in that case. Next, here we can see Khulna main municipality. We have distributed this portion. After that, this portion contains the area of Mongla and Bagherhat. You may be in confusion that how here is Bagherhat, here is Bagherhat, why Mongla is in the middle of there. Actually, in this case, Bagherhat contains this portion, northern portion, and Mongla contains this southern portion. A 2 line has been out from there to Mongla area. Next, Here is Bhandaria, which is near Barisal district. Is the Barisal area, Barisal city, and a power plant named Samit coming from that area. After that, we can see Borguna, Potuakhali. Finally, the portion of Paira has been shown. Recently, another power generation plant coal-based in Paira has been introduced, but we have ignored that portion. Now, how we have classified fault? Initially, I have showed that here is a fault, here is another fault, here is another fault. Now I have shown a sample. This is a fault. If we zoom it, you will find it like this. We set fault on a certain position and select a three-phase voltage current measurement near the location of fault, which measures the voltage and current of that faulted network, faulted bus. If we double click on fault, we will find the logo like this. Sorry, this logo. Here you can see phase B and phase C are shorted and phase A is not connected with the system, and this duration is from you see here we have set our system frequency 50 Hz, so it will run from 2 by 50 to 4 by 50, means 2 cycle occurs with fault. Next, here we can see our output result. It will be like this, and we have selected our sample data in this ratio so that our simulation work faster. This portion will give us the voltage reading, and this scope will give us current reading. Next, when we read our voltage and current, you see initially our system works properly. After 2 complete cycle, fault occurs and there was some anomaly like this and like this. This is in voltage and this is in current. This is LL fault. After that, we tried to extract this time series data. To do so, we have clicked here, a new command box appear here. We came to logging, set for save format with structure with time. Finally, we have got this data set in this form in a structure mode in MATLAB. And when after that we need to convert this data, this array, into CSV file to train in the Python network. To do so, we have write this 4-line code, convert the current into convert I into LL voltage and convert a variable V to LL current, see LL current and LL voltage. 2 CSV file has been generated in the same folder. After different tile like LL, LLG, triple L, we will generate a dataset like this, where you can see 3-phase current value, 3-phase voltage value, and here GCBA means ground, C phase, B phase, A phase. Here all are 0 means there is no fault. Here B 1C1 means B and C are shorted, and it is an example of LL fault. And after these two example, 0 1 1 1 means three phase line are shorted, which become an example of symmetric fault. And 1 0 0 1 means A, and phase A and ground is connected, which is an example of LG fault. And ground, phase B and phase A is connected, is example of LLG fault. After we train this type of data set into our network, here you can see conventional neural network model. Here our 6x1, okay, this IA, IB, IC, VA, VBC, VC, this 6 portion become our input data, and we convert this 4 number into a single point and become our one output data. So you can see 6, 1 input data, output data. Input, then our first convolution layer, then second convolution layer. First of all, we increase it, we flattened it. After we dense it, we drop out. Finally, we returned our output like this. Now, in case of gated recurrent network model GRU, number of steps become lower, but this model is also effective in case of one-dimensional data modeling. Here our total parameter was too high, you can see. Next, decision tree classifier. In most of the case, decision tree classifier has given us the best result. It works like this, like take a data, compare between two. If yes, go another tree, another branch. If no, go another branch, in this way. After final training, this became our total accuracy rate of different model and for different power plant. Here at the end point at Satkhira, there was no power plant. We have set a fault between the transmission line coming from Khulna, and here decision tree classifier and decision tree classifier performs better. And here in case of Summit, both CNN and GRU model worked well, and in case of Orion, only GRU model performed less better. Actually, it became decision tree classifier model. This was all about our explanation. Now I am going to demonstrate a video of the portion. Then here, this is our total network. After that, this is the portion of Barisal, this is the portion of Khulna. I have already simulated it, so I can see you the data in the scope. I can see the value of, you can see the value of voltage, three-phase voltage. You can see the value of three-phase current, and this is the current after fault. Next, there is another portion. I told in my video that we have clicked here, go to logging, and we have set structure with time. Okay, Next, we went to our MATLAB command, and now there are two command for generating two CSV file. I am running it. Okay, I am running it. V and I, two CSV file will be generated here. Okay, I am going to this. Okay, this I, here this you can see I is generated in the same way V was generated in CSV file. Based on this CSV file, we have generated the following data set, like this. This is the data set of Satkira fault occurring. We have generated GCBA in this pattern. In the same way, this is Orion, and rest of the example was like this: Satkira, then Orion. This is the data set from Orion. You can see GCBA 000. After a certain point, this parameter was changes. 1011 means LLG fault, and total input data was 2,40,002 in each data set. After that, now I am going to show our training model in GitHub. This is for Khulna Orion training model. Here you can see our confusion matrix for CNN model. It works better, but not better in case of not fault location, no fault location. Next come our GRU model. In this way, this is our decision tree classifier. It performs best. Next came Satkira portion. In the same way, we have trained our data, generated confusion matrix, and finally accuracy rate has been shown here. In the same way, this portion KPCL same has been done. Another portion, this portion is of Summit dataset, maybe is Summit dataset. Yes, this was our training network, and finally this is the last. It is NW PGCL dataset. This is our model, and this is our confusion matrix, CNN, GRU, and classifier network tree. Okay, thanks for watching. This is all about our work. Thank you for watching.